Hello children, today we are going to learn about the chapter statistics of mathematics from the class 10th. As we already know from the chapter statistics in class 9th, we have learned about how to group the data and how to present the data in the various forms. In class 9th, we have mostly dealt with the ungrouped data. But in class 10th, we are going to learn about how to find the different measures of central tendency of the group data. The various measures of central tendency that we are going to discuss today are: the first one, the measures of central tendency. The first one that we will discuss is how to find the mean of the given grouped frequency distribution. And the second one, that is mode of the given frequency distribution. And at the last, we will learn about how to calculate the median of the given data. And then we will learn here how to draw the different cumulative frequency distributions and how to find the median graphically with the help of those cumulative frequency distributions. Those are known as ogives. Let us try to find how we can calculate the mean of the grouped frequency distribution by using the first measure of central tendency, that is the mean. For the mean of the data, we have the various mathematical formulae by which we can find the mean of the given frequency distribution. What are the various measures of the, what are the different formulae that we will use to calculate the mean? The first one, that is known as the direct method. And what is the mathematical formula for the direct method by which we can calculate the mean of the given data? That is x bar. X bar represents the mean of the given data, and the formula for this is we take the product of the addition of the product of frequencies by the respective variables under the study, that is fi multiplied by xi divided by the sum total of the frequencies. This is known as the direct method. Second one, that is known as the shortcut method. Shortcut method, or the other name of it is known as assumed mean method, in which we will learn how we assume the mean of the given data in the tabular form and how we calculate that. Assumed mean method. Assumed mean method. And the third one, that is of the mean, which we will discuss, that is the third one, that will be step deviation method. All the three methods we are going to discuss step by step, and we will learn how we can calculate the mean of the given data by these three methods. And the mathematical formula for step deviation method is, that is x bar is equal to a plus summation fi ui divided by sum total of the frequencies multiplied by the class size. Similarly, for the assumed mean method, we have the formula. Likewise, we in assumed mean as well, we have the A here, the assumed mean, like in step deviation, A plus summation of Fi multiplied by Di whole divided by summation Fi. This is the formula for the direct method. Then we have the formula for the shortcut or the assumed mean method, and then we have the last one, step deviation method. If the values, why we use the different methods, that is the direct, shortcut and the step deviation method for the calculation of the mean of the data. First one, if the data values are simpler, the data values are not too much large, then we can easily go for the direct method. And if the data values are larger, that in that case we can reduce the given data, we can go for the step deviation or the shortcut method or the assumed mean method. Dear students, let's take the example by which we can understand the concept how we can calculate the mean of the given data by using these formula. Let us take one example from your textbook, that is, the given data is there and we are supposed to find the mean of the given data. Let us take one example from the textbook, that is exercise number 14.1 from your textbook. A survey was conducted by a group of students as a part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of the plants per house. In the given data, we have to find the mean number of the plants per house. Let us first write what is the variable under study, that is the number of plants here. Number of plants we write here. Then in the second column we have the frequency, that is the number of houses. Number of houses. And then in the third column we will have the mid values of these groups. Let us first write what are the data values given. 0 to 2, number of houses 1, 2 to 4, that is 2, 4 to 6, that is 1 here, 6 to 8, we have here 5, 8 to 10, 6, then we have the next values, 10 to 12, we have 2, and 12 to 14, that is here 3. So these are the given data values here. Then we have these number of houses, this is the frequency. We generally can denote it with the help of Fi, frequencies of the various groups. Then we calculate the mid values of the given groups, that is the class mark, that is represented with the help of the variable under study, that is xi. Then in the last one we are supposed to find the product for Fi dot xi, because we must remember that to find the mean of the given data, what we are going to learn here, we are trying to learn here the direct method. That is the first method to calculate the mean of the given data, and for which what are the parameters required in the formula, that is addition of all the values of Fi multiplied by xi divided by the addition of all the frequencies, that is summation of Fin to xi divided by summation of Fi. Let us try to find the values, product of Fi xi, then take the addition from the table, and again we will take the addition of the frequency, all the frequency from the table, and let us do the calculation for that, so that it will be then easy for us to calculate the values. See, xi, how we calculate, that is the lower limit plus upper limit. Here the lower limit is 0 and the upper limit is 2. How we calculate the first one? Let us see. It is 0 plus 2 whole divided by 2. That will give us the mid value, that is 2 by 2, that will be equal to 1. Similarly, 2 plus 4, that is equal to 6 whole divided by 2. So that will be 6 divided by 2, that is equal to 3. Next value, 4 plus 6, that is equal to 10. So 10 divided by 2, that will be equal to 5. 6 plus 8, you can see that's 14, that is divided by 2, 7. 8 plus 10 is 18 divided by 2, that is 9. You can see throughout the data values here, you can see the gap of the 2, 2, 2, 1 plus 2 is 3, 3, and the common gap is maintained in between the values. And 10 to 12, it is 22, that will be 11 here, and then it is 13. Now in this column, as the formula is written there, fi multiplied by xi. So we have to multiply the frequencies with the corresponding xi values. That is the variable under study. Let us multiply. 1 multiplied by 1, fi is here 1, xi is here 1. So it is 1 multiplied by 1, it is 1. Then 2 multiplied by 3, it is 6. 5 multiplied by 1, it is 5. 7 multiplied by 5, it is 35. 9 multiplied by 6, it is 54. And then it is 22. And this is 39. Now, dear children, you can see, as from the formula, we need to find summation of fi and summation of fi xi. So what we have to do, the next step is to add all these values. So first of all, we'll add all the frequency. That is mathematically written in this manner, summation. This symbol stands for the summation, summation fi. That is sum total of all the frequencies. You can see, after adding these frequencies, that is 2 plus 1 is 3, 4 is 9, 9 plus 6 is 15, 15 plus, and it is 20 here. Then we have to add all these frequencies. 6 plus 1, 7, 7 plus 5 is 12, 12 plus 4 is 17, 21, 21, 23, and it is 32. It will be 3 is carried here, 3, 3 is 6, 5, 11, 11 and 5, it is 162 total. So what we need to do is here, this value is simply the addition of fi into xi. So simply what we need to do here is use these values here for the formula, which will give us, which implies x bar will be equal to summation of fi xi, that is 162, and then summation of fi, we can see from the table, that is 20, and then you can cancel it out, that is x bar is equal to, it is 2 8s, 2 1s and 2 10s, and in short it will be 8.1. So this is the required value that we have found with the help of the direct method. This is the direct method by which we have found here the mean of the given data. Now, dear children, let us see, as we have different various methods in calculating the mean of the given data, let us see what is the next method, that is the shortcut or the assumed mean method, for which we will take the next question from your textbook. Let us see. This was the question number 1. Do remember, it was from the exercise 14.1, question number 1 of the exercise. Let us try to see, with the help of the next method, how we can calculate the mean of the given data. This was from the direct method, because we have to learn one by one all the methods. And kindly note one point, that if in the examination you are asked to find the mean of the given data, then the option is yours. You can opt for any of the method. But particularly if the option is written in the question that you have to follow a particular method, then you have to stick to that method. Now let us see one more question from the textbook to understand the next, that is the assumed mean method. It's a question number 2 from your textbook. Question number 2. Consider the following distribution of the daily wages of the 50 workers of a factory. Daily wages are given and the number of workers are given, for which the distribution is here. You can see we are going to calculate the various parameters in this table. So various columns will be there added. One or two columns more will be added. Here are daily wages. Daily wages. And then in the second column we have number of workers. That's also good. Let us try to write first what are the values given here. It is 100 to 120, 120, 140, 140 to 160, 160 to 180, and then at last it is 180 to 200. And what are the corresponding frequencies for these data values? That is, for the first one it is 12, 14, 8, 6 and 10. And in the next column we need to calculate, in the next column we will calculate here the xi values. That is a class mark, we simply denote by xi. Then from these xi values we will see how to select an assumed mean, and with the help of which how we can calculate the deviations. In this column we will calculate the xi, then we will calculate in the next column the deviations. Deviations are the values actually, difference of all the variables under study with assumed mean. And then in the last column we will find fi multiplied by di. That is product of fi di. Dear children, as you remember that we discussed the formula for the calculation of the mean, that is x bar, with the help of the assumed mean, is mathematically written as a plus summation of fi di divided by summation of fi. And this we need to remember the formula for how to calculate the assumed mean from the given data. Let us see how to calculate the various parameters out of the given data xi. That, as we know, as we did in the previous question, same we have to do it here. That is 100 plus 120 divided by 2. That will be equal to 100 plus 120, that is equal to 220 divided by 2. That will give us 110. Likewise, we have to calculate the various values. 120 plus 140 divided by 2, that is 260 divided by 2, it is 130. 140 plus 160 divided by 2, that will give us 300 by 2, that is 150. You can see the gap of the 20 and 20 is maintained throughout, so we can directly write it is 170 and then it is 190. Now we have to choose out of these xi values, that is the variable under study, daily wages. We have taken the mid value, that is the class mark of the given data. Now out of this we have to assume one of the value as to be the mean of the given data. Let us see if here it is very simple and easy for us to select the assumed mean. Here the number of observations you can see 1, 2, 3, 4, 5. As the number of observations is odd, so it is very simple to select. We can select the middlemost observation, middlemost data value as the assumed mean. This we will take as the assumed mean. Now the question arises here, if the number of data values, that's even. In that case, we have to take the middlemost two observations from the given data, and out of these two, we are at our choice. We have the option to select the upper or the lower value as the assumed mean of the given data. Now you can see in the next column we have to take the difference of xi minus a. What are the xi values? That is here the first one is 110. 110 minus with a is here 150. So 110 minus 150, that will give us the minus 40. Again, 130 minus 150, that will give us minus 20. 150 minus 150, that will give us 0. 170 minus 50, that is equal to 20. 190 minus 150, that will give us 40. And remember, if the number of observations are odd, and this is the famous result as well, the deviations from the mean is always equal to 0. If we take the addition of all the deviations that has been taken from the assumed mean, you can see that will give us the result as equal to 0 here. So this is one of the important results that you must remember. And then in the next column you can see we have to take the product of the frequencies with the corresponding DI values, that is the deviations. Now number of workers, as you are aware that this we denote at the frequency. Now Fi multiplied by Di, we have to take, so 12 into minus 40, so that is equal to minus 480. 14 multiplied by minus 20, that is minus 280. 8 multiplied by 0, that will give us 0. 6 multiplied by 20, it's 120. And 10 multiplied by 40, that is 400. Now we have to take the summation of these values, summation of Fi Di. Summation of Fi Di, here summation of Fi. Summation of Fi. As we are given in the question as well, the addition of the frequencies that was already given there, that is the number of how many workers were present, that is 50. The number of workers are 50 there, and some of the rough work needs to be done here. After adding in the negative and then positive, we'll get a result of minus 240. Then what we have to do, we simply use these values in the given formula to calculate the mean of the given data with the help of the shortcut or the assumed mean method. X bar will be equal to A, that we have selected from the given observations, that is the assumed mean. A is equal to 150. 150 plus summation Fi Di, that value is there, that is minus 240, whole divided by summation Fi, summation of addition of the frequency, that is 50 here, and little bit of cancellation has to be done here, 0 and 0, then it will be negative, 5 ones, 5 fours, and then 5 eights. It will give us minus 4.8, and after subtracting these two values we'll get it will be equal to 145.2. And dear children, this is the mean of the given data. It is somewhere around the assumed mean that we already had selected, that is 150. It is near about, the 150 is near about value to the 145. To some extent it is closer to the, as the name suggests, these are the measures of center and tendency, and these give us the value. We show the tendency towards the central values of the given data, and these are the values by which all the data values are represented, and these are the representative, these are the only one values around which all the values surround. They are surrounded, the single value or these single values, that is the measures of center and tendency, these are surrounded by all the other data values, and these are the representative of the given data. This was the second method that we here we calculate the mean of the given data with the help of the assumed mean method. Now let us see the third one that we discussed earlier, that is known as the step deviation method. Same data values. As we earlier discussed, that why we are using the direct method, assumed mean, and the step deviation method. That is the direct method. If the data values are smaller, we can go for the direct method. If the data values are little bit larger, the calculation will be little bit larger, for which we can go for the assumed mean method. Or next we can use still again, if the values are still larger, then we can go for the third one, that's known as the step deviation method. Let us see what is the step deviation method and how we can use it on the numerical problems to calculate the mean of the given data. Let us take the question number 9 from your textbook to understand the concept of step deviation method. Question number 9 says the following table gives the literacy rate in percentage of 35 cities. The literacy rate of the 35 cities has been recorded in the tabular form. Find the mean of the literacy rate. What is the table for that? That we are going to write here. What are the data values that are given here? Remember, this is question number 9 from your textbook. In the first column, we'll write, here there will be little more addition in the columns of this table. Let us first see the first one, the literacy rate. Literacy rate, I am going to write shortcut LR in percent. This is percent. The first group is 45 to 55, then 55 to 65, then 65 to 75, 75 to 85. You can see the common width is maintained there, then 85, and this is the last one, that is 95. You can see this is the continuous frequency distribution. Now let us see what are the number of cities that have been for which the data values are recorded. The number of cities are, in the first one we have, we'll write number of cities. Number of cities, it is 3, 10, 11, 8, 3. This we can denote by Fi. Then in the next one we have to calculate the Xi, that's the mid values. Then in the next column we will calculate Di, that is deviations from the mean. As we know, that is equal to Xi minus A, that is variables under study. We have to take the difference to the assumed mean, that we will select from the Xi values. And then the one more addition is there, Ui, that is equal to Di divided by H. H here stands for the class size, that is for the given data values. And in the last one we will find the product, that is Fi multiplied by Ui. Dear children, we need to remember the result of how to calculate the mean from the step deviation method. And what is the formula for that? We must first remember the formula for that is X bar A plus summation of Fi multiplied by Ui divided by summation of Fi multiplied by the class size, that is H. This is the mathematical formula by which we can calculate the mean by using the step deviation method. Let us see what are the different parameters that we have to complete this table. Xi, that is the mid value or the class mark of the given data. As we know, that is 45 plus 55, that is the lower limit plus the upper limit whole divided by 2. So 45 plus 55, it will give us 100 divided by 2, that will be equal to 50. This will be the first value. Similarly, 55 plus 65, that is the next value of the data, that will give us equal to 120 divided by 2, that is equal to 60. Likewise, we have 65 plus 75, that will give us equal to 75, it will be 65 plus 75, that is 10, 140 divided by 2, that will be equal to 70. And you can see the common gap is maintained between the data values. It is 50, 10, 60, 70, then we'll go the next values 80 and 90. Then in the next column we have to calculate here. We have to calculate here the deviations from the assumed mean, that is di, here xi. Out of these xi values we can select one value as the assumed mean. As here also you can see the number of observations, the data values, you can see 1, 2, 3, 4, 5, that is the given data values are odd. So we can choose the middlemost observation, that is here 70. That can be chosen as the assumed mean A. And now we have to take the difference of the respective xi values with this assumed mean. The first one is 50 minus xi value. First one is 50 and the assumed mean 70. It will give us minus 20. And then 60 minus 70, it will give us minus 10. It will be 0. Then 80 minus 70, it will give us plus 10 and 20. And you can see the deviations from the mean. You can see that will give us the result equal to 0. Now, to reduce further these values, as we have discussed earlier, that we can use the step deviation method to reduce further the values to make our calculations easier. Here, di values, that is the values of this column di, are to be divided by the class size h. H, you can see the class size, that is the upper limit minus the lower limit of the respective groups. That will give us here h. We can write h is equal to 10. So we have to divide the given values, all the values here, by 10. So 20 by 10, this will be minus 2, it will be minus 1, it will give us 0, this will give us 1, and this will be 2. Now what next? We need to multiply fi values with ui, that is these values. Fi are these, 3 multiplied by 2, that will be equal to minus 6. Then 10 multiplied by minus 1, that will give us minus 10. 11 multiplied by 0, that will be 0. 8 multiplied by 1, that will give us 8. 3 multiplied by 2, that is equal to 6. Do remember, we are taking here the frequencies, that is fi from this column, the number of cities, and multiply it with the ui values, that is from this column. All the values are to be multiplied. Then in the formula, as it is evident, we have to take addition of the fi multiplied by ui. So we have to take the summation of fi multiplied by ui. That will give us, it will be minus 2. After calculating the value, you can see it is minus 2. And addition of all the frequencies. As the number of cities, as it is evident here in the book as well, as the number of cities that were discussed in the given question, that is 35. So we will write summation of fi here as 35. Now it is very simple for us to calculate the mean by using step deviation method. We know, which further implies that x bar will be equal to a. A we have selected from the given data, that is 70. 70 plus summation fi ui. Fi ui we know that is equal to minus 2 whole divided by fi, that is equal to 35 from the table, and multiplied by h, that is the class size here. Class size, that is equal to 10. So multiplied by 10. That will further give us 70. It will be minus 20 divided by 35. And after we can take the simple calculations, that is very easy now. It is 5 4s, 5 7s. So that is 70 minus 4 by 7. Now we can go for the division. 4 divided by 7, it will be 0.0. it will be 7 5s 35, it will be 5, further we can bring it 0 here, so it is 7 7s 49. Further likewise, let us take our value to up to the 2 place of the decimal. This will be taken as 70 minus 0.57. So after subtraction we'll get, it will be 69.43. we have calculated as the mean of the given data. We have taken our value, as you can see, we assumed earlier that let 70 be the mean of the given data, and it is 69.43. It is very much closer to the given value. 70 and 69.43 are very much closer, and this is, dear children, this is how we can calculate the mean of the given data by step deviation method. And today we have discussed here all the 3 methods, that is the direct method, second, that is the shortcut or the assumed mean method, and the third one that we discussed here, that was step deviation method. In this way, we have used all the 3 methods which we are supposed to, by which we are supposed to find the mean of the given data by using all the 3 methods. Now, the another measure of the central tendency that we are going to discuss, that is the mode of the given data. As earlier in the class 9th, you have understood well the definition of the mode of the given data, that is the most frequently occurring observation of the given data. But in class 9th, we have learned how to calculate how to find the mode of the given data values, but the data was ungrouped. Here in class 10, we have to discuss if the data values are having the grouped frequency distribution, how we can calculate the mode of the given data. And what is we have to discuss first, what is the formula for calculation of the mode of the given data. That is the most frequently occurring observations of the given data. Let us go for then, that is our next topic, that is how to calculate the mode of given data. All the 3 measures of central tendency are very much important from the examination point of view. Our exercise 14.2 is based on the mode of the given data. Mode of the given data. Mode, what is the mathematical formula to calculate the mode of the given data? Let us see. The mode is equal to L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 multiplied by H. And what are the different parameters here? L. L is to calculate the mode in the given frequency distribution, that will be tabular frequency distribution, that is grouped also. And we need to classify, we'll take the numerical example later, and we need to classify first of all the model class. The group of the given data, that group which is having the highest frequency of the given, from the given data values. So L means the lower limit of the model class. That class which is the model class, which has the highest frequency. Out of that, what is the lower limit of that class? So L stands for lower limit of model class. Model class. Similarly, we have to go F1 first of all, let us see what is F0. F0 is the frequency of the class preceding the model class. That is, which comes before the model class. Frequency of class preceding, which means which is the class which comes before the model class. We have to take the frequency of that class. Frequency of the class preceding the model class. Then we have F1. F1 is the frequency of that class for which we have decided which is the model class. That is from the highest frequency. So frequency of the model class. That is, in short, we can write frequency of the model class. Then we have F2. F2 stands for, likewise, we had F0, the frequency of the class preceding the model class, but F2 stands for the frequency of the class, frequency of class succeeding the model class. That is, which comes after the model class, succeeding the model class. Then we have H. H, as we know, H is the class size. That is size of the classes of the given data values. So first of all, we must try to understand what is the formula by which we can calculate the mod of the given frequency distribution of the group data. That is L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 multiplied by H. What are the different parameters that we use in the formula? L, that is the lower limit of the model class. F0, that is frequency of the class preceding the model class. F1, frequency of that same class. F2, frequency of the class succeeding the model class. And then at last, H, that is the class size of the given data. Now let us take one numerical example to understand the concept of how to calculate the mod of the given data. Let us take one example from our textbook. That will be by taking the numerical example, all the concepts will be clear regarding how to calculate the mode of the given data. Mode is simply, as we know, the data value which has the highest frequency, which is repeated maximum number of times, which is the frequently occurring observation of the given data. Let us now see, taking one example from the textbook. That will be from the exercise 14.2. It is question number 1. The question number 1 says that the following table shows the ages of the patients admitted in a hospital during a year. That is, age of the patients is given and the number of patients that has been admitted in the hospital, for which we are supposed to find the mod and the mean as well. Mean already we have discussed in the 14.1 exercise, that we are not going to discuss here. We will only discuss here how to calculate the mod of the given data. Let us take the different values. The first of all, there is age in years. The age of the patients, age in years. Age in years has been given, and number of patients for which the data values are also given. That is, we denote by Fi. Age in years, it starts from 5 to 15, that is 15 to 25. The gap of the 10 is maintained, so it is 25 to 35. Then we have 35 to 45. Then it is 45 to 55. And at last we have 55 to 65. That is the last value. Now out of the frequencies, you can see The first one is 6, 11, 21, 23, 14 and 5. This is the table. For we don't have to add more columns. We simply have to choose out of the given values first the model class. The model class, as we know, is that group of the data which has the highest frequency. As it is evident from the table, you can see here the group which is having the highest frequency, that is here 23. This is out of all the frequencies, it is 6, 11, 21, 23, 14 and 5. Out of all the frequencies, you can see this one here 23 is the highest frequency, and the class corresponding to this frequency, that is here this one, this class 35 to 45. This class is taken as a model class, as the class is having, as this class 35 to 45 is having the highest frequency, that is 23. And as we know by the formula, that is how to calculate the mod of the given data. Here mod of the given data, mod is equal to, from the formula, L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2 multiplied by H. These are the values that we are going to use from our table. So what is the frequency? That is equal to 23, that is frequency of the model class. This is taken as F1. As we have discussed earlier in the formula, the frequency of that model class. And the frequency which is here, that is 21, which is the frequency which comes before the model class, that is the class preceding the model class, that is equal to F0, and the class which is succeeding the model class, that is here having the frequency as 14, so this is taken as F2. And lower limit of the model class, here you can see from the table, that is taken as L. L here is equal to 35. Now we can use these values separately in the formula. Here we need to write first what is here L is equal to. Before that, we need to find the model class. Here the model class. Much better is to write first the model class. Model class we have seen from the table is 35 to 45. 35 to 45. And now L, that is the lower limit of the model class, that is equal to 35. Then we can take F0. F0 is 21. F1. F1 is 23. Then we have F2. F2 is equal to 14. And the class size H. You can see from the table, the gap of the 10 and 10 is maintained throughout the data values, that is equal to 10. Now simply what we have to do, use the values in the given formula. So the mod will be equal to L, that is equal to 35 plus F1. F1 we know that is equal to 23 minus F0, that is equal to 21. Then 2 multiplied by F1, 2 times F1, that is multiplied by 23. Then minus F0, that is equal to 21. Then the next value, that is equal to F2. F2 is equal to 14. And H, that is equal to 10. This value here equal to 10, which is equal to further 35. We have to do the simple calculations now here. So that is 23 minus 21, that is equal to 2. And here it is 46 minus 35 multiplied by 10. Further, this can be written as, we can wrap this table to write the further calculations here. which implies further mod of the given data is equal to 35 plus, that is 2 divided by 11 multiplied by 10, or in short we can write it here 20. That is equal to 35 plus, we can do little bit of rough calculations here. Let us see, 20 divided by 11, 11 ones, it is 11, and it is 9.0118, so that is 88. Likewise, we can do the further, and let us round it off up to one place of decimal, 1.8. So after adding 35 plus with 1.8, that can be taken as 36.8. That is the mode of data which we have calculated here. So dear children, today we have discussed the mean of the given data and the mode of the given data. Mean, these are the two measures of standard tendency that we discussed here today in the first lesson of our video, that's of the statistics. First we discussed today the mean of the given data by three methods. Number one, the shortcut, that is the direct method. Number two, shortcut method. Number three, the step deviation method. And then the next measure of the measures of standard tendency, that was the mode. And we learned how to calculate with the help of the mathematical formula the mode of the given frequency distribution, which is grouped. Thank you very much. That's all for today, and hope to see you in the next part of the video.